Intraplate Volcanoes, Anomalies in Tectonic Theory. Title: Intraplate Volcanoes, Anomalies in Tectonic Theory. Introduction, 100 words. Tectonic theory is the cornerstone of our understanding of Earth's dynamic geology. It explains the movements of the lithospheric plates, leading to the formation of volcanic and seismic activity below. Plate boundaries. However, there exist certain geological phenomena that challenge this theory. Intraplate volcanoes, also known as hotspot volcanoes, are one such anomaly. These volcanoes emerge far from plate boundaries, often in the middle of tectonic plates, defying conventional tectonic explanations. This article explores the nature of intraplate volcanoes, examines their occurrence, and discusses the possible explanations behind their unconventional locations. Explaining plate tectonics, 200 words. To comprehend intraplate volcanoes, it is crucial to grasp the concept of plate tectonics. According to this widely accepted theory, Earth's lithosphere is divided into several rigid plates that flow on the semi-fluid asthenosphere. These plates interact along three main types of plate boundaries: convergent, divergent, and transform. At convergent boundaries, two plates collide, causing one to subduct beneath the other, leading to intense volcanic and seismic activity. At divergent boundaries, two plates move away from each other, creating gaps where molten material rises to form new crusts. At transform boundaries, two plates slide past each other horizontally, generating shear stress and potentially triggering earthquakes. Intraplate volcanoes definition, 200 words. In contrast to volcanoes located at plate boundaries, intraplate volcanoes defy the conventional understanding of plate tectonics. These volcanoes emerge within the interior of tectonic plates, geologically isolated from the shifting dynamics of plate boundaries. The most iconic example of an intraplate volcano is the Hawaiian Islands. Hotspots and mantle plumes, 300 words. The prevailing explanation for intraplate volcanoes lies in the concept of hotspots and mantle plumes. Hotspots are areas of anomalously high heat flux in Earth's mantle, typically associated with regions of upwelling material from the deep mantle. These upwellings, known as mantle plumes, are believed to be fixed in their location relative to the moving tectonic plates. As a plate moves over a hotspot, a volcanic chain may form. The classic example of this is the Hawaiian Emperor Seamount Chain. The Hawaiian Islands, being the youngest, are geologically active, while the older islands and the chain have eroded and subsided beneath the ocean. Some intraplate volcanic provinces appear unrelated to known plate tectonic features. Furthermore, the mechanism responsible for generating mantle plumes and their persistence over geological timescales remains a subject of ongoing scientific inquiry. Some researchers argue that the movement of tectonic plates alone is inadequate to produce the long-lived, stable plumes required to generate long chains of intraplate volcanoes. Intraplate volcanism also challenges the principle that plate boundaries are the sole loci of volcanic activity. It demonstrates that there are additional sources of heat and molten material in the mantle that can erupt through the lithosphere independently of plate tectonic forces. Intraplate volcanoes continue to defy conventional tectonic theory, challenging our understanding of Earth's dynamic geology. These volcanoes, also known as hotspot volcanoes, emerge far from plate boundaries, often in the middle of tectonic plates. To comprehend intraplate volcanoes, it is essential to grasp the concept of plate tectonics. According to this widely accepted theory, Earth's lithosphere is divided into rigid plates that interact along convergent, divergent, and transform boundaries. Convergent boundaries involve plates colliding and causing volcanic and seismic activity. The divergent boundaries create gaps for molten material to rise. Along transform boundaries, plates slide past each other horizontally, generating shear stress and potentially triggering earthquakes. In contrast to volcanoes at plate boundaries, intraplate volcanoes defy conventional understanding. These volcanoes emerge within the interior of tectonic plates, geologically isolated from plate boundary dynamics. The prevailing explanation for intraplate volcanoes lies in the concept of hot spots and mantle plumes. Hot spots are areas of anomalously high heat flux in Earth's mantle associated with upwelling material. These upwellings, known as mantle plumes, are believed to be fixed in location relative to moving tectonic plates. As a plate moves over a hot spot, a volcanic chain may form. However, this explanation does not account for all complexities of intraplate volcanic occurrence. An alternative explanation suggests that stress changes induced by global plate movements could trigger volcanism by reactivating ancient faults and fractures. Additionally, the mechanism responsible for generating mantle plumes remains a subject of ongoing scientific inquiry. Some argue that plate movement alone is insufficient to produce the long-lived, stable plumes required for long chains of intraplate volcanoes. Intraplate volcanism challenges the notion that plate boundaries are the sole loci of volcanic activity. It indicates the presence of additional sources of heat and molten material in the mantle that can erupt independently of plate tectonic forces. The study of intraplate volcanoes challenges the conventional understanding of plate tectonics and provides valuable insights into Earth's dynamic geology. These volcanoes, also known as hotspot volume canoes, deviate from traditional volcanic activity occurring along plate boundaries, instead manifesting within tectonic plates. Convergent boundaries occur when two plates collide, resulting in volcanic and seismic activity as one plate subducts beneath the other. Divergent boundaries arise when two plates move away from each other, creating gaps where molten material ascends, forming fresh crust. Transform boundaries witness plates sliding horizontally, producing shear stress that can provoke earthquakes. Intraplate volcanoes challenge our conventional understanding by emerging deep within tectonic plates, seemingly detached from the dynamic plate boundaries. The Hawaiian Islands serve as an illustrative ion of intraplate volcanism, formed as the Pacific Plate migrated over a hot spot. This allowed magma to penetrate the crust, culminating in the formation of a volcanic island chain over millions of years. The prevailing theory behind intraplate volcanoes lies in the concept of hot spots and mantle plumes. Hot spots denote areas in Earth's mantle with unusually high heat flux, often associated with upwelling material. These upwellings, known as mantle plumes, are believed to be stationary relative to the moving tectonic plates. As a plate traverses a hot spot, a volcanic chain may emerge. The Hawaiian Ian Emperor Seamount Chain provides a classic example, where the Hawaiian Islands represent the youngest and most active part of the chain. Nevertheless, the hotspot theory does not comprehensively explain all aspects of intraplate volcanic occurrences. Some intraplate volcanic regions appear unrelated to known plate tectonic features. An alternative hypothesis suggests that stress changes induced by global plate movements could potentially reactivate ancient faults and fractures, triggering volcanism. Further challenges arise in understanding the generation and persistence of mantle plumes over geological timescales. Some argue that the movement of tectonic plates alone cannot generate the long law. Sting, stable plumes required to sustain long chains of intraplate volcanoes. The existence of intraplate volcanoes challenges the notion that plate boundaries exclusively host volcanic activity. It underscores the presence of additional heat sources and molten material within. The mantle, capable of erupting independently of plate tectonic forces. In summary, intraplate volcanoes pose a fascinating enigma that defies conventional tectonic theory. Intraplate volcanoes, also known as hotspot volcanoes, are a phenomenon that challenges the conventional understanding of plate tectonics. These volcanoes emerge in unexpected locations, far from PL. 8 boundaries, and often in the middle of tectonic plates. To grasp the nature of this anomaly, it is essential to understand the concept of plate tectonics. According to plate tectonic theory, the Earth's lithosphere is divided into rigid plates that interact along convergent, divergent, and transform boundaries. Convergent boundaries involve the collision of 2 plates, leading to intense volcanic and seismic activity. Divergent boundaries occur when 2 plates move away from each other, creating gaps for molten material to rise and form new crust.